So good morning, everyone. My name is Luis Cordeiro, and I'm going to present the Switch2Steel Workshop today. And this workshop is organized by a partnership between OneSource, an SME in Portugal, University of Coimbra, Civil Construction Department, CMM Association, and INSIS Research Institute. These activities are co-financed by Centro 2020, Portugal 2020, and the European Commission. So today the agenda will start with a couple of presentations about the project that we have been developing in the last years, and we will start with an introduction to the fire safety in the industrial buildings by Aldina Santiago, then a presentation about the platform that was developed throughout the project by myself. We will go then to a presentation about the background in the algorithms and the design and optimization of buildings. We will have a short break afterwards. And then the presentation about the optimization on fire protection. Then finally, we will have a presentation by Nicola Tondini about the behavior of steel pipe racks subjected to localized fires. And at the end, we will have a closing session, Q&A, and we will be able to answer questions that you may have. So to start the workshop for today, we will start with our presentation by Aldina Santiago. Aldina Santiago is Associate Professor at the University of Coimbra, with a PhD in structures and mechanisms of materials. The research activity from Aldina is mainly on behavior of structures subjected to accidental actions like fire, impacts and explosions, and robustness of structures.
Okay, good morning to all of you. My presentation is about the fire safety design for industrial buildings and infrastructures. I organized this presentation in 4 topics. I will start first with the overview of the problem, and after I will go more in detail about the legislation and about the fire safety design in this type of buildings. Okay, the 2 main questions that we need to answer at the beginning is what it means industrial buildings and infrastructures in this scope. And after we have a second question, why it's so important to make and to be aware for the fire safety design for this kind of buildings. So I will start first with, I will try first to answer the first question. So, when we are speaking about industrial buildings and infrastructures, but first in the industrial buildings, we are speaking about warehouses and distribution, and I have some topics about what it means, these warehouses and distribution. It is used for storage and transportation of goods, and normally we have a single-story building with a large dimension, normally with areas higher than 500 square meters and with a height higher than 15 meters. But we are also talking about manufacturing facilities with heavy equipment, with normal, and this is very important for this subject, fire safety design, normal, this kind of building with 3-phase electrical power, with a high capacity of ventilation and a high system of exhaustions. And also in general, these buildings also have pressurized air, water lines with floor drains and storage tanks. But we are also talking about refrigeration and cold storage, normally used for food products with small or large rooms for cooling and freezing. And we are also talking about buildings for telecom and data hosting centers. Again, large facilities with extensive computer services and associated equipment, with normally redundant power supply, with heavy equipment, and if you can see here, normally with a strong floor to support this high equipment. And about infrastructures, we may say the tunnels, the terminals, large compartments, at least in one direction, in this case, with a high ventilation. So we have here some examples, at least 6 examples of the scope of the buildings that is in the scope of this presentation. So this is, we try to answer to the first question. And now about the second question. Why is so important to take into account the fire safety design for this kind of buildings? Probably because I'm more aware about this issue in the last times, but if you find in the news, at least in Portugal, but I think it is around the world, you saw that we have a lot of news about fires in this kind of buildings. For example, in the last weeks, we saw a fire in the cod processing factory here in Coimbra. We had another fire in a recycling factory in a marsh in the north of Portugal. And again, in the north of Portugal, a fire in a refrigeration factory in Vila de Conde. So, and I also tried to find official numbers, and from 2021, the last official numbers that we have a number of 654 industrial fires in Portugal. What it means, more or less, or near 2 fires per day in industrial buildings. So this is too large. The number of fires in industrial buildings is too large, and this is the reason why we started this project, and this is the reason why we now, at the end of the project, we have this seminar. So, and what are the main causes of the fires? The hot works, mainly in manufacturing factories. We have also the combustible dust. This kind of fire with this combustible dust are fires that the temperature increase very, very fast, and fires where it is very difficult to stop and to extinguish. But we have also In warehouses, we have also as a cause of the fires the flammable liquids and gases. We have also the bad maintenance and sometimes human errors in equipment and machinery. And the most critical causes of the fire in this kind of buildings are the electrical assets. We know that normally 20% or more than 20-25% of the fires in industrial buildings are due to electrical hazards. So, and in terms of impact, first we have the human life. Normally these buildings are factories with a lot of works, and the main attention, the first attention is for the human lives, the safety of the human life. But we have also the properties. We have in these buildings, we have equipment, very expensive equipment, machinery, raw material, all of them normally very expensive, where the damage and sometimes the destruction of this equipment will contribute for large financial losses. But we have also to take into account the environmental. In these buildings, sometimes we have other materials, we have chemics, and due to the fire, they could contribute to the toxic gases, they could contribute to the air pollution, they could contribute also to the contamination of the waters. And of course, at the end, we have the loss and the interruption in the economy and in the business of these factories. So now I will pass to the second point, and the second point is related to the legislation. I will start first with the presentation, overview, a short presentation about the Portuguese legislation for this kind of buildings, and after I will make a comparison with the European legislation. So starting with the Portuguese legislation, we have two documents. A decree law number 123, the last version is from 2019, and we have a technical regulation 1532, and the last one is not from 2008, but the main contents is in the version of 2018. So in the first document, we have the organization of the different types of buildings and enclosures. We have defined, at this moment, we have defined 12 standard use for the different buildings. And for each one, they are organized in 4 risk categories. Okay, after I will show how to calculate this risk category. In the second document provides the technical regulation for the fire safety design in terms of fire behavior, insulation, fire protection. So first we make a characterization, and after we will do the fire design. So starting with the first document, as I said before, we have 12 standard uses. All of them are here. And for this specific case, for the industrial building, we have in the standard use number 12, industrial buildings, workshop, and warehouse. And after, as I said, we need to calculate the risk category. We have 4 risk categories from the first to the 4th. The first one is a reduced risk, and the 4th category is a very high risk. How to calculate this risk category? There are a table that is defined in this decree law that it allows to calculate this risk category based on the number of floors below the ground floor, and also based on the modified fire load. This modified fire load, it is calculated, could be calculated based on a deterministic approach or based on a probabilistic approach, but in both cases, this modified fire load, it depends of the materials, it depends of all of the contents of the compartment, in this case, the industrial compartment. Okay, so after that, it is possible to define what is the risk category for our building. And after, we have this table in the second document, in the technical regulation, where it is possible, based on the utilization type, in this case 12, and after to calculate the category of risk, it is possible to calculate the fire resistant time. And the fire resistant time, it could be for the first risk, the first category of risk, it could be 60 minutes or 180 minutes. The minimum in the Portuguese legislation for this kind of buildings is a fire resistance time of 60 minutes. What it means that I need to design all the structural elements to resist during 60 minutes. Okay, and now the comparison with the English legislation and also to the French legislation. It is easy to see that the way how to calculate this fire resistant time, it is different. As I showed before, in the Portuguese one, it is based on the modified fire loading. But for the English one, it is based on the height of the building, and after it is considered if I put sprinklers or not. In the Portuguese legislation, it is also imposed to put sprinklers, but they are not taking account in the design, the calculation of the modified fire load. I need to put sprinklers in the building, but after I disregard them in the design. And in the French legislation, the fire resistant time is calculated based on the number of floors. So again, what another difference? If you see the minimum resistance time in the English legislation could be 30 minutes, in the French legislation could be 15 minutes, and in the Portuguese legislation is 60 minutes. What it means that our legislation is much more severe than the similars in other countries of Europe. And now I go to the third topic, the principles of the fire safety design. First, starting with the fire safety of the industrial building, the main concepts. First, the fire prevention, okay? A good maintenance of the equipment, for example, but also the fire detection and the alarm system, the detection of the smoke, the detection of the flames, but also the need but this is imposed on the design, the emergency planning and evacuation. All of the occupants of the building should know and should understand the fire evacuation plan. And after the existence of fire suppression systems, for example, sprinklers, the good storage of the hazard materials, the continuous training and education of the workers, and at the end, and probably more directed to our seminar, the design of the structure according to the standards and taking account the necessary fire protection for the structural elements. And now looking to this last topic, the structural fire protection, we could take two approaches for the design, and I divided these two approaches taking account the typology of the buildings. If we have a small compartment, it is possible to assume that we have a uniform temperature in all the compartments. So it is possible to assume the same temperature in each point of the compartment, and this temperature could be calculated based on the nominal curves that we have in the standards. However, if you have large compartments with non-uniform temperature, with large ventilation, it is very difficult to have a uniform temperatures. So the nominal curves that I have in the small compartments are not possible to use in this kind of compartments. And we have for the industrial compartments, we have this situation. So the linear rules, the linear equations that we have in the standards is not possible to apply for this kind of buildings. In this kind of buildings, we should make the design based on the real performance of the building and taking account all the conditions of the building. And according to the Eurocodes, it is possible to do first, when we have, as I said before, a well-defined compartment, it is possible to do a prescriptive approach design. And in this prescriptive approach design, we made the design based on nominal curves. we have, for example, the well-known ISO 834. And after that, we made the analysis of the structure. That could be the analysis of elements, substructure, or the entire structure. And after that, we made the design of the elements or the substructure or the structure. And the design for the elements, for example, it could be based on tables, tabulated value, not for the steel structures, but for example, for the concrete structures. It is possible to do a design based on tabulated values, and after it is possible to do the design based on simplified equation or more sophisticated equations. When is needed to use a design performance-based design, I put two times design. So we have, for sure, we have more complex calculations. Yes, it's for sure, but we have a more precise response, and to have the correct response in each point of the compartment. It is possible to have the variation of the temperature in each point of the compartment. It is possible to know the transport of smoke. It is possible to know the transport of heat. We have all the details in the compartments. So in this case, we have more accurate design, and sometimes it could be a more economic design too. So, and if you see in this layout from the Eurocode, when we use a performance-based design, the design of elements of substructures are not allowed using tabulated values. In this case, we could use for the elements, we could use simplified models, but after, for the substructure and for the entire structure, we need to use advanced models and normal finite element models. Okay, and now I go to the fourth point, structural protection and fire-resistant materials. So according to the legislation that I shown before, we should divide the measures, the fire protection measure, in two types. Active measures, and I already mentioned some of them, like for example, the sprinklers, the smoke detector, the flame detector, and the passive fire protection measures. In this case, because I'm looking now for the construction materials, I'm focused on the passive fire protection measures. And in the passive fire protection measures, I have to take into account two different systems. First, the structural system, and for the structural system, I need to ensure the stability and the integrity of the building in case of the fire. But when we have also non-structural systems, we need also to take into account the limit of the propagation and the fire development. And now to account these two topics, there are tests, there are standard tests, and the first one is a fire reaction test. What it means, the fire reaction tests are tests that evaluate how the material contributes to the development of the fire, how do they contribute to the beginning, to the development, and to the propagation of the fire. Okay, and based on in these tests, it is possible to classify the materials in different classes. Class F, what it means that these materials has no performance under fire. Okay, and class A, it means that this material has a good performance under fire. It is non-combustible material. And we could say that in class A, we have the concrete, we have the glass, we have the stones, we have the steel. Okay, these materials don't contribute to the ignition and to the development of the fire. And now the second topic is about the other tests, the fire-resistant tests. In this case, I'm not evaluating the behavior of the material, their contribution to the fire, but I'm evaluating the structural system in terms of their resistance in fire, load-bearing capacity, insulation, and integrity. Okay? I put load-bearing capacity, insulation, and integrity. We have here in the lab, we have furnaces where it is possible to evaluate this fire resistant capacity of horizontal and vertical elements, and it is possible to apply different curves, different thermal load in these elements, the standard curves, but also parametric curves. Okay, after that, after to show the reaction and the resistance of the materials, I go directly to the standards. And the design of this kind of elements is based and is made according to the Eurocodes. We have first the Eurocode 1, and the Eurocode 1 is the Eurocode to define the loads. And in this case, because I'm looking for the fire, for the thermal loadings, I should look to the part 1.2. Okay, Eurocode 1 part 1.2 is related to the thermal loadings. And after I need to go to the design. And the design, there are several Eurocodes. The part related to the fire is always the part 1.2. Eurocode 2 related to concrete, Eurocode 3 related to steel, Eurocode 4 related to composite structures. Okay, normally this kind of buildings, industrial buildings, are constructed by steel elements. I put here some of the advantages of these steel elements, but I think all of you know, but I will focus in, I think that is one of the most important advantages for this kind of buildings. Design flexibility, allowing future expansion and facility to a fast construction. I think, of course, all of them are advantage of the steel, but I think the third one is the advantage that is directly to this kind of buildings, the industrial buildings. So, I shown before fire reaction and fire resistance, how to behave the steel according these two types of tests. First, fire reaction. As I said before, steel is a non-combustible material. It's in place class A. Okay, very good. But the problem is about the fire resistance. And when I look to the fire resistance of steel, I know that the strength of steel degrades very fast with the increase of the temperature. I also know that the thermal conductibility of steel is very high, around 15. For concrete, I think it's 1, 2, more or less. And we know that the steel profile have a slender, it's very, very slender when compared, for example, for other cross sections. So the temperature increase very fast in the cross section of the steel. I put here to show, I said before, that the strength of steel degrades very fast. I put here the curves of the degradation of the properties of steel with the temperature from 20 degrees to 800 degrees. I have some notes. The steel softened progressively from 100 to 200 degrees up. The steel began to lose strength above 400 degrees. Only 23% of ambient temperature strength remains at 700 degrees. At 800 degrees, strength reduced to 11%, and at 900 degrees to 6%. And normally, the temperature in a fire, in this kind of building, is around 1,000, 1,200, or less like this. So this values of temperature is the normal temperature in a fire in a compartment like that. And the steel melt at around 1,500 degrees. I have here also the degradation and the comparison of the degradation of the yield strength with the elastic model. The stiffness reduced much more faster. Here, the thermal properties, the variation of the thermal properties with the increase of the temperatures. And I think this is one of the advantages of this project, because normally in the design we consider the thermal properties at ambient temperature. And in this project, we also consider the variation of the thermal properties, not only in the steel, but also in the protection of in the materials used for the protection of the structure. Okay, and to finalize, some remarks about thermal insulation and flame propagation. We need to take into account first the fire protection measures. We need to use fire-resistant materials, as I said, for class A, but we need also to consider fire barriers, fire stop, fire-resistant insulation. We need to take into account the compartmentation. Normally, these industrial buildings are as I said at the beginning, they have a large area, but it is necessary to have a compartmentation taking account the material that we have in these buildings, a division of the structure into fire-resistant compartments or using fire barriers to prevent the spread of fire and smoke. And it is necessary also a continuous fire modeling and safety system. Okay, thank you very much.